Okay, so now let's do a couple more examples of the same kind. For example, let's say that you have a resistor that is, for example, R is equal to 1000 ohm, and this sort of resistor we usually call it, an electronics engineer or even a hobbyist would call this, for example, 1 kilo ohm resistor. And I will show you, of course, what a resistor looks like. A resistor is basically something like this. For example, if you go to there is a website all about circuits.com, and for example, if you go to this website, is of course an electronics community. There is many books over here that you can read about direct current, alternating current, semiconductors, digital electronics. There's a reference, experiments, and so on and so forth. But if you search for example, resistor color code, for example, they give you calculator and chart, and then a resistor basically looks something like this. So normally a resistor, which is basically called a through-hole resistor, looks something like this. These are your two leads, and there is some colors over here, like the 1, 2, 3, normally, for example, 4 strips or 5 strips or 6 strips. And these colors tell you about the value of the resistance of this resistor. If you go for an actual resistor with through-hole resistor, image, for example, see, this is a resistor. This is a resistor basically. This length would be, for example, something like 10 millimeters, 8 millimeters or so, and the diameter, this is like a cylinder, and the diameter is like something like 3-4 millimeters or so. So that's basically a resistor. And of course, voltage is not something that you can see. It comes out of something called a power supply unit, benchtop, for example, benchtop power supply unit, and it would be something like this. For example, you see this is a B&K Precision 9129B, and it's basically a box like this. You have these terminals over here. For example, on this power supply you have 3 channels, channel 1, channel 2, channel 3, and then you can set the voltages and the currents that you want. For example, you want to limit the voltage to, for example, 10 volts and, for example, 2 amps. You set that, you dial all of those values in on this keypad and then enter, and then the voltage or the potential difference between these two terminals becomes, for example, 10 volts. And you can do the same thing for example, this output over here, this output over here, and usually these outputs are isolated. Sometimes even the ground is isolated. These terminals over here are the ground. Sometimes it's important that the ground is also isolated, not connected together. Sometimes that is the case in some power supply unit, sometimes not. So your voltage is not really something that you can see. It's a difference in potential between these two terminals, and that has something to do with the electric charges and things like that. That of course you cannot see, but you can measure it using a multimeter. You can put a multimeter on here, digital, for example. If you go for benchtop, digital multimeter, you would get something like this. For example, you would get something like this, and this is a multimeter. The output of your outputs of your voltage, you can think of this as a battery. These outputs, using some two pieces of wire, you can connect to these inputs over here, and then this multimeter tells you, for example, what's the voltage on, for example, on these two terminals over here. That's how you measure a voltage. Of course, we will see that in our projects. So we saw about the resistor. We saw what the resistor was. Now you know what a voltage source is. That's a power supply. That's how you measure a voltage. And using this, you can also measure a current. It does have a ammeter as well. So using the ammeter in this multimeter, you can measure amps as well, and then your current, basically the current that is going through your circuit, you can see. So that means that then the three values, the resistance, the voltage, and the current, are basically those three things that basically are related to any electronic circuit, as long as you have a closed circuit, meaning that you have a power source meaning that you have a power source that goes to a resistor. This is a resistor, or a lamp it could be, and then it is connected to other terminal of the battery. So this is a closed circuit. If I open it like this, the circuit is not closed, and the voltage is present here on these two terminals, but there is no current going through the circuit because the circuit is not closed. So these are the three values, or the three parameters, that you have in any electronic or electric circuit. Now, suppose that you have a 1000 ohm resistor, which is R is equal to 1000 ohm, or a 1 kilo ohm resistor. Let's say that a current of 0.01 amp is going through your circuit, which is basically 10 milliamps. You would call this a 10 milliamp current, and 10 milliamp is the same thing as 10 into 10 raised to the power negative 3 amps, which is equal to 10 raised to the power negative 2 amps, which is equal to 1 over 100 amps, which is equal to 0.01 amps, 100th of an amp, which is this value over here. So this is 10 milliamp. And now if this current is flowing through your circuit through this resistor, what is the voltage required for this to happen? So there you want to calculate your voltage. So then your voltage would be equal to I times R, as we discussed before. V is equal to I in amps, which is 0.01, times the resistance, which is 1000 here. So you have 10 volts DC, of course. 10 volts DC. Or basically suppose that you have a 20 ohm resistor. So you have a resistor, for example, 20 ohms, and basically a current of 1.5 amps. 1.5 amps is going through your circuit. What is the voltage that needs to be applied? What is the voltage that needs to be applied to this circuit so that this current starts flowing through your circuit? That would be 1.5 times 20, which is around 30 volts or so, I suppose. So V is equal to IR. So V is equal to basically 1.5 times 20, which is equal to 2 times 15 is equal to 30, and then 300, and then 1 decimal point, that's 30 volts. And of course you can rearrange this formula in order to calculate anything else that you might need. For example, let's say that you have a voltage of 1 volt flowing or applied to a circuit, and you have your circuit is basically nothing but a 2 ohm resistor. You have a 2 ohm resistor in there. So now you want to know what sort of current is going through this resistor, meaning that your resistor is over here and you're applying a voltage of 1 volt over here. Your resistor is 2 ohm. You want to know the current that is going through this circuit. What is your I? So in order to calculate that, so you know that, for example, V is equal to IR. So we said that if we divided both sides of this equation by an R, we would get V divided by R is equal to IR divided by R. These two would cancel out, so I is equal to V divided by R. Now I know the value of my voltage is 1, and the value of my resistance is 2, so that's half an amp. So I is equal to half an amp. I over here is equal to half 0.5 amps. And you would call this current 500 milliamps. Nobody says, yeah, you could say half an amp. Some people say you could call it half an amp, but usually 500 milliamps. For example, 0.3 amps, you wouldn't call it 3/10 of an amp. You could do that, but you would call this, for example, 300 milliamps. Okay, that's basically, for example, what you would do when you talk to, I mean, this is just so people would understand you when you're talking about a circuit or something. Otherwise, 0.3 amps is the same thing as 300 milliamps, of course. Or let's say that you have a voltage of 2 volts applied to a circuit with a resistor of 10 ohms. R is equal to, for example, 10 ohms, and you want to calculate your current. Again, we said that I is equal to V to R. So your I is equal to basically 2 divided by 10, which is equal to 1/5 of an amp, which is, I think, 0.2 amps, which is 200 milliamps. You need to learn basically these fractions. You need to learn them. for even, I mean, for in mathematics, in physics, and all, everywhere you will need them, and I do need to do the same thing as well. I never took the time to learn these or to memorize these fractions. So 1 divided by 5 is equal to 0.2. 0.2. So this is 0.2 amps, which is the same thing as 200 milliamps, for example. Or let's say that you have a voltage of, for example, V is equal to 10 volts and R is equal to 3 ohm, and so to calculate your current, again, you can write I is equal to V to R, which is equal to 10 divided by 3, 10 thirds. 10 thirds is the same thing as 0.0333 repeating. You would write this as you would write this as 0.3 repeating, I suppose. 10 thirds is 3.33, that is 1 thirds. So 10 thirds is 3.33333 repeating. So you would write this as well, 1 thirds is the same thing as 0.333 and so on and so forth, which you would write as 0.3 repeating. But 10 thirds is 10 times that, so your decimal point goes one placeholder to the right, so you would get 3.333 repeating. So you would get 3.3 repeating. Usually you round this to, for example, 3.3 amps. you round this to 3.3 amps. But of course, if you were to use this if this was some final answer, for example, if this was some final answer and you were not going anywhere with this anymore, you would probably write it as 3.3 amps. Otherwise, if you were to use this again in the rest of your calculation, you would, I would keep this as 10 thirds. 10 thirds is basically giving me all the precision of this number. But then when I write it as 3.3 amps, that the precision of the number, of course, is lost. So in calculation, you just keep this as 10 thirds and then use it in the other stage of the calculation. Otherwise, if you're done with the calculation, you can basically round it to 3.3 amps and that would be basically the end of your calculation. Now suppose that, for example, your voltage is, for example, 120 volts, and these are all DC voltages, of course. And suppose that your resistance is 100 ohms. So then your current would be V to R, which is equal to 120 divided by 100, which is equal to 1.2 amps basically. Now you can again do the same thing, rearrange this formula in order to calculate resistance. So we said that V is equal to IR. Divide both sides of this equation by I, you will get V divided by I is equal to IR divided by I. Cancel these two out, and so you will get R is equal to V to I. R is equal to V to I. and you can use this relationship or this equation in order to calculate resistance when you have voltage and current over here. So for example, if you have for example some voltage of 1 volts, if you have some voltage of 1 volt and for example some current of 1 amps, to calculate the resistance, R is equal to V to I, which is equal to 1 divided by 1, which is equal to 1 ohm. And I know that this is in ohm and not any, basically not any multiples of ohm, because I've entered my voltage in volts and I've entered my current in amps. For example, suppose that the current had been given to me. Suppose that the current had been given to me as I is equal to 1000 milliamps. 1000 milliamps. So 1000 milliamps is the same thing as, of course, 1000 into 10 raised to the power negative 3 amps, which is the same thing as 1 amp. The same thing over here. So what that means is that basically the 1000 milliamp is the same thing as 1 amp, right? So if I write this as 1000 milliamp, suppose that my current had been given to me this way, and then I want to calculate, for example, R in this situation. So then R, as we discussed, was V is equal to R is equal to basically V to I. So I write my voltage as 1 volt, for example, and then and for the current, suppose that I enter this number over here, which is related to my current, but then the unit over here is milliamp, not amp. But suppose I made a mistake and I wrote this 1000, and that is 0.001, for example, ohm, I suppose. Let's say 0.01, and that's basically 1 milliohm, right? That is 1 milliohm. Now the actual resistance in this circuit is 1 ohm and not 1 milliohm. But since I entered my current wrong, then I got my resistance wrong over here. So you need to be careful about that. Meaning that, for example, suppose that the current is given to me as, for example, I is equal to 1000 milliamp, and I want to calculate the resistance. So the resistance is V to I, basically. The resistance is V to I. So before I entered some value for the current into this circuit, not circuit, but equation, I need to write this as 1000 milliamp as 1 amp. And now I can enter this number into the equation, write the voltage as 1 volt and the current as 1 amp, and that gives me 1 ohm, and that's the correct value for the resistance, basically. Or suppose that, for example, I don't know, your voltage is 10 volts, and the current going through the circuit is 3 amps, and the current is 3 amps. So then what you need to do is basically calculate your R, which is equal to V to I, and basically you have 10 volts to 3 amps, which is something about 3.3 basically ohm or so. So that's basically the whole story. Now there's a part about resistors that we will talk about in the next video, and we'll have some calculations related to power and that sort of thing. So I'll see you in the next video.